Preparing for Amazon SDE interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you solve the two-sum problem, and what is its time complexity? I would scan the array once while storing previously seen values in a hash map. For each number, I calculate target minus number and check whether that complement already exists. If it does, I return both indices, otherwise, I store the current value and index. This gives O(n) time and O(n) space, compared with O(n) squared, nested loops. I would also clarify whether duplicate values are allowed and preserve the required index ordering. While answering, explain the brute force baseline, hash map optimization, complement lookup, duplicate handling, early returns, complexity analysis, and why the chosen data structure improves performance. Question 2. How would you find the longest substring without repeating characters? The engineering idea is maintaining the longest valid window while scanning once. I keep a left pointer and a map from each character to its latest index. When a repeated character appears inside the window, I move left to one position after its previous index. I update the maximum length after every step. Each pointer advances at most n times, so the algorithm runs in O(n) time with O(k) space for the character set. Make sure to cover the sliding window invariant, two-pointer movement, last seen indexes, duplicate characters, Unicode considerations, linear complexity, and why the window never needs to move backward. Question 3. Design an LRU cache with O(1) get input operations. An LRU cache needs fast lookup and fast ordering updates, so I combine a hash map with a doubly linked list. The map points keys to nodes, while the list keeps most recently used entries near the head and the least recent near the tail. Get moves a node to the front, put updates or inserts it, then evicts the tail when capacity is exceeded. Both operations remain O(1), excluding synchronization overhead. In your answer, describe the hash map plus doubly linked list combination, recency updates, eviction of the tail node, capacity handling, thread safety considerations, and constant time guarantees. Question 4. How would you determine whether a binary tree is balanced? I would define a balanced tree as one where every node's left and right subtree heights differ by at most 1. A bottom-up recursive function returns the subtree height, or a sentinel such as -1 when imbalance is detected. That avoids recalculating heights for every node. The traversal visits each node once, giving O(n) time and O(h) recursion space. I would also clarify that an empty tree is balanced. Be sure to mention recursive height computation, bottom-up validation, the balance condition, sentinel failure values, avoiding repeated traversal, empty tree behavior, and O(n) time complexity. Question 5. How would you detect a cycle in a directed graph? For a directed graph, I use DFS with 3 states: unvisited, visiting, and completed. If DFS reaches a visiting node, it has found a back edge and therefore a cycle. After exploring all outgoing edges, I mark the node completed. I start DFS from every unvisited vertex because the graph may be disconnected. This runs in O(v plus e) time and O(v) space, including the state array and recursion stack. Focus on depth-first search coloring or visitation states, distinguishing active and completed nodes, disconnected components, recursion stack logic, iterative alternatives, and O(v plus e) complexity. Question 6. When would you use dynamic programming, and how would you formulate a solution? I use dynamic programming when a problem has overlapping subproblems and an optimal solution built from smaller optimal solutions. I first define precisely what each state means, then derive a transition, establish base cases, and choose memoization or bottom-up tabulation. For climbing stairs, dp I equals dp I1 plus dp I2. Because only 2 prior values matter, I can reduce space from O(n) to O(1) after confirming the recurrence. In your answer, explain overlapping subproblems, optimal substructure, state definition, transitions, base cases, memoization versus tabulation, space optimization, and validation with small examples. Question 7. How would you make a multi-threaded component thread safe? I begin by identifying shared mutable state and writing down the invariants that must always hold. I prefer immutable data or thread-safe collections where possible. Otherwise, I protect compound operations with a mutex or use atomics for simple counters. Locks should be small and acquired in a consistent order to prevent deadlocks. I would test with stress and race detection tools, then measure contention because correctness alone does not guarantee acceptable throughput. Discuss shared mutable state, invariants, mutexes, atomic operations, lock scope, deadlock prevention, visibility, immutability, contention, and testing under concurrent schedules. Question 8. How would you optimize a slow SQL query used by a high-traffic service? I would first reproduce the query and inspect its execution plan rather than guessing. I would check for full scans, expensive joins, poor cardinality estimates, missing composite indexes, and unnecessary columns. Then I would test an index whose leading columns match common filters and ordering, while considering right cost and storage. For large result sets, I would use keyset pagination. Finally, I would compare latency and resource usage under realistic production-like load. Make sure to cover query plans, indexes, selective predicates, joins, cardinality, avoiding unnecessary columns, pagination, statistics, caching, and measuring before and after changes. Question 9. How would you design a reliable REST API for placing orders? I would expose a post endpoint for creating an order and require an idempotency key so client retries cannot create duplicates. The service validates items, authorization, inventory, and payment state, then returns a stable order identifier and an appropriate status. I would model order transitions explicitly and reject invalid updates. Timeouts, structured errors, metrics, tracing, and backward compatible versioning make the API safer for mobile clients and dependent services. Cover resource modeling, validation, authentication, idempotency keys, status codes, retries, optimistic concurrency, timeout behavior, observability, and backward compatible versioning. Question 10. Design a URL shortening service that can handle high read traffic. I would generate a unique numeric ID, encode it with base 62, and store the mapping from short code to destination URL. A stateless API layer can handle requests behind a load balancer, while a replicated key value store supports durable mappings. Since redirects dominate traffic, I would cache hot entries and use read replicas. The design must address expiration, malicious URLs, rate limits, analytics asynchronously, and collision-free ID generation. Discuss key generation, collision avoidance, redirect latency, database partitioning, caching, expiration, abuse prevention, analytics, availability, and read versus write workload assumptions. Question 11. How would you design a notification system for email, SMS, and push messages? I would separate notification creation from delivery using a durable queue. A dispatcher reads events, checks user preferences, selects the appropriate provider adapter, and sends through channel-specific workers. Retries use exponential backoff with jitter, while a dead letter queue captures persistent failures. Idempotency keys prevent duplicate sends, and provider rate limits are enforced per tenant. I would track attempted, accepted, delivered, and failed states for operational visibility. Focus on asynchronous queues, provider adapters, user preferences, retries with backoff, dead letter queues, rate limits, deduplication, delivery status, and monitoring provider failures. Question 12. How would you design an inventory service that prevents overselling? I would treat inventory as reservable stock rather than immediately reducing availability across every system. A conditional database update can reserve units only when available quantity is sufficient, making the operation atomic. Each reservation has an idempotency key and expiration time, Confirmed orders convert it, while abandoned reservations release it. Events update search and recommendations asynchronously. Periodic reconciliation compares inventory records with orders to detect and repair drift. Be sure to discuss atomic reservation, database constraints, transaction boundaries, expiration, ID impotency, concurrency control, eventual consistency, failure recovery, and reconciliation workflows. Question 13. What caching strategy would you choose for a read-heavy Amazon service? For most read-heavy services, I would start with cache aside. Read the cache, fetch from the database on a miss, then populate it with a bounded TTL. Updates and validate or refresh affected keys. I would add jitter to expirations and request coalescing to reduce cache stampedes, and shard hotkeys when necessary. The right strategy depends on consistency. Product descriptions may tolerate staleness, while inventory requires stronger coordination. Explain cache aside, TTLs, invalidation, consistency requirements, hotkeys, stampede prevention, eviction policies, cache failures, and when write through or write behind is appropriate. Question 14. How do you choose between strong consistency and eventual consistency? I choose based on the business invariant, not personal preference. Payment authorization and inventory reservation need strong coordination because stale reads can lose money or oversell. Search indexes, recommendations, and analytics can be eventually consistent because delayed updates are acceptable. I would document the guarantee, such as read your writes or monotonic reads, and design reconciliation for asynchronous paths. Under network partitions, the choice reflects whether availability or immediate correctness is more valuable. In your answer, compare correctness requirements, latency, availability, partition behavior, user experience, read your writes guarantees, reconciliation, and examples from orders, catalogs, and analytics. Question 15. How would you test a service before releasing it to production? I would test at multiple layers. Unit tests verify business rules quickly, integration tests validate databases, queues, and external contracts, end-to-end tests cover critical customer journeys. I would add load tests for latency and capacity, security checks for authorization, and failure injection for dependency timeouts. Tests should run automatically in C with isolated data and meaningful coverage. A gradual deployment with metrics and rollback criteria provides the final safety net. Cover unit, integration, contract, end-to-end, load, failure injection, security, and regression testing, along with test data isolation, automation, observability, and deployment gates. Question 16. Describe how you would debug a production latency regression. I would first quantify when the regression began and which endpoints, regions, or customer cohorts are affected. I would compare recent deployments, inspect latency percentiles, error rates, saturation, and distributed traces, then identify whether the bottleneck is application code, a database, or a dependency. If impact is severe, I would roll back or disable the feature while investigating. After reproducing safely, I would fix the root cause and add a regression monitor. Mention defining the regression, checking dashboards and deployment history, tracing requests, comparing cohorts, isolating dependencies, reproducing safely, rolling back, and documenting the root cause. Question 17. Tell me about a time you demonstrated customer obsession. In one project, customers repeatedly abandoned checkout because a validation error appeared only after submission. I reviewed support tickets, watched session recordings, and reproduced the flow on slower networks. I redesigned validation to happen inline, clarified the message, and added telemetry. Completion improved by 14% and support contacts declined. I learned that customer obsession means investigating the actual experience, not merely delivering the originally requested feature. Use the STAR structure, define the customer problem, quantify impact, explain direct customer evidence, describe trade-offs, and connect the outcome to Amazon's customer obsession principle. Question 18. Describe a failure or mistake and what you learned from it. I once shipped a batch job without testing its behavior on a large dataset, causing it to exceed its processing window. I took ownership, paused downstream consumption, and reran the job safely. The root cause was an inefficient query and missing scale test. I optimized the query, added representative load tests, and introduced runtime alerts. The experience taught me to validate operational limits, not just functional correctness, before calling work complete. Be honest without blaming others, explain your ownership, impact, immediate mitigation, root cause, preventive actions, measurable learning, and how the experience improved future decisions. Question 19. Tell me about a time you disagreed with a technical decision. A teammate favored asynchronous integration for simplicity, while I worried about dependency, latency, and cascading failures. I shared a small load test comparison and proposed an asynchronous design for non-critical updates, while keeping the core request synchronous. We reviewed the trade-offs together and chose the hybrid approach. Once the decision was made, I supported implementation fully. The result reduced tail latency and preserved a straightforward customer-facing workflow. Focus on respectful disagreement, data gathering, customer and business impact, communicating trade-offs, seeking alignment, committing after decision, and avoiding personal criticism. Question 20. How would you approach a coding problem during an Amazon SDE interview? I start by restating the problem, clarifying constraints, and walking through a small example. Then I describe a straightforward solution before improving it with an appropriate data structure or algorithm. I state time and space complexity, identify edge cases, and code in clear, testable steps. While implementing, I narrate decisions and run through examples manually. If I receive a hint, I use it productively, verify the invariant, and explain trade-offs. Be sure to mention clarifying requirements, examples, brute force, optimal approach, complexity, edge cases, clean implementation, testing aloud, and responding constructively to hints. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.